All right, so 8.1. So I've made a little chart on the board. And what end behavior is talking about is what's happening at either end of a graph. Or both, and there's only 4 options, right? Either both ends can be going up, or both ends can be going down, or the left side can be going down and the right side up, or opposite of that. So here's what you're going to do to decide what the end behavior is. You're going to find what's called the degree of the polynomial, which means what's its highest exponent. Its highest exponent is what's going to determine its end behavior. If the highest exponent is an even number and the term is positive, for instance, like if you had 3x squared, your exponent is even and the term is positive, that's telling you that either end of the graph is going to both sides are going to be pointing to the up. They're going to end up both pointing up. If your exponent is even, like squared or to the 4th power or to the 6th power, but your term is a negative, right? The negative x squared did what to the parabola? It flipped it upside down. So that if you are an even exponent, but the term is negative, that means both ends are going to be pointing down at the end of your graph. Now, different stuff can be going on in here, okay? But even positive, both up, even negative, both down. So what if your exponent, your highest exponent is an odd number, like to the 3rd power or to the 5th power? That means if the term is positive, that means you're going to go up from the left side to the right side, which means you're going to start at the bottom and then you're going to travel up throughout your graph. So this is what it's going to look like if your exponent is odd and your term is positive. And if you're odd and negative, you're going to start at the top and then travel to the bottom, travel going down throughout the graph. So we're going to use this to answer, looks like the first 4 problems. Give y'all a second to get that down. Okay. Number 1. Number 1 says, select the following from the following 4 sketches that describes the end behavior of the graph of the given function. So it's going to give you a function. Let's see, this one is the square root of 11 x to the 3rd plus 2x squared minus 4x plus 5. Okay, we're not going to draw this function or anything. We just want to know what would the end behavior be. So what I'm looking for is the term, there's 4 terms here, the term that has the highest exponent, which would be this to the 3rd power. So this is the term I'm looking at. That's what's going to give it its end behavior. Okay, so what am I looking for? I'm looking for the exponent, which is odd, and the term. It doesn't matter that it's a square root. I'm just worried about whether it's positive or negative. So the exponent is odd and the term is negative. Oh, it's not negative. There's not a negative. I don't know what I'm thinking. The term is positive. So let's see. I'm losing it. I'm losing my mind. The exponent is odd and the term is positive, which means its end behavior It's going to start at the bottom and travel up. Okay, number 2, the same kind of problem. Okay, we're just using that chart. Negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 5. So again, we're finding the term that has the biggest exponent, which is this term right here. This time, the exponent is even. It's an even number. And the term does have a negative in front of it, so it is even and negative. Even always means your end behavior is going to be the same on both sides, either both up or both down. But if it's even and negative, that means they are both going to be pointing down. All right, number 3. Be careful on number 3. You've got f of x equals negative 3.1 x to the 4th plus x to the 6th plus 0.1 x to the 7th. Now remember, you're not looking for the front term. You're looking for the term that has the biggest exponent. The term that has the biggest exponent is this x to the 7th back here. So its exponent is an odd number. And the term is positive, right? Because it's not minus, it's plus, which means it's odd, positive, which again means it starts at the bottom and travels up throughout the graph. All right, last one like this. F of x equals 2 plus 1/2 x to the 4th minus 1/7 x to the 3rd. So again, looking for the term that has the highest exponent, which is this middle term this time. So its exponent is an even number. So look at the sign since it's positive. What does that tell you about the end behavior? Both sides will be going up. Okay. Now, when we do 8.2 next week, this is really going to help us choose what graphs that we're looking at, simply knowing what the end behavior of a graph is going to look like. All right, number 5. It says use the substitution to determine whether 3 is a 0 of the following. So f of x equals x to the 3rd minus x squared minus 8x squared, plus 13x plus 6. So x to the third minus 8x squared plus 13x plus 6. And it wants to know, is 3 a zero of the function? Which means, is this, if I graph this, which is one way to solve it, if I graph this, would it cross through? Remember what zeros are. They're x-intercepts. Would this graph cross through the x-axis at positive 3? Substitution is another method to see if that is true. So I'm just going to replace. Substitution means exactly what it says. Substitute the x's with 3's and see if it equals 0. So 0, let's see if this really will work. So put in 3 for the x. So 3 to the third power minus 8 times 3 squared plus 13 times 3 plus 6. So again, I just replaced all those x's with 3's. If I wanted to, I could do this all in one step in my calculator by punching in exactly what this side says and see, and then hit enter and see if it does equal this 0. So you would type in 3 to the third. Okay, and it's not going to hurt to put in those parentheses. It's a good practice to get into, especially if your number was negative. So open parentheses, 3. To go up into your exponent, hit this up arrow. That puts your cursor up in the exponent. My exponent is 3. Now it's going to stay up into the exponent until I tell it I'm done typing exponent, which I am, right? Because I want to come back down here and do minus 8. So hit the right arrow and watch the cursor. When you hit the right arrow, it brings you back down. So then you'll put minus 8, open parentheses, 3, close parentheses. Now, when you're doing squared, it has its own button. You can use the same method that we did for this 3 and go up arrow 2. But if you're doing squared, you can just hit the squared button. Because watch what it does when you hit it. It puts the exponent up there and brings you back down to the regular spot. So minus 8 times 3 squared plus 13 times 3 plus 6. So again, I just typed in exactly what was on the board and hit enter. And it does tell me that it is equal to 0. So this, yes, 3 is a 0 of the function because when you replace all the x's with it, you do get a 0. Which means if I did put that in my y equals and graphed it, one of the places it's going to cross the x-axis is at positive 3. Okay, before we get into the next few problems, we're going to be finding zeros of a function and then stating what what's called their multiplicity is and what that means. Okay, before we get into that, let's look at a couple different types of factoring that we need to familiarize ourselves or re-familiarize ourselves with. One of them is the difference of squares. Because when you have a function, in order for you to find the zeros without graphing it or find its x-intercepts without graphing it, it needs to be in fact what's called factored form. You need to see all the separate factors written out instead of the long polynomial. So if you run into something while you're factoring that looks like this, and you have two terms, okay, x squared minus 25. This is called the difference of perfect squares, which means both terms are what we call perfect squares, which means I can break them down into two numbers that are the same. And when I multiply them together, I can get x squared and 25. For instance, what times itself? This is going to factor into two separate factors. What can you put here and here? And if you multiply them together, they're going to be the same thing. And if you multiply them together, they equal x squared. The only way you can get x squared using the same thing is x and x. I can also do the same thing with this 25. What numbers can you put here and here that they're going to be the same number? And when you multiply them together, you get 25, which would be 5 and 5. And when you're factoring the difference of two perfect squares, your factors are going to have one positive and one negative, and it doesn't matter which order they go into. So that's how you factor the difference of perfect squares. Another example would be, right? Those are both perfect squares. So I can factor that difference of squares. Again, x and x gives me x squared. What number that when you multiply it times itself gives you 49? That would be 7 and 7. And again, 1 plus and 1 minus. So looking at number 6. Says find the zeros of the function and state the multiplicity of each. Okay, what you're looking for is any kind of parentheses that has a squared in it. That means it's not all the way factored out. That means you need to simplify it or take it and factor it another step. Okay, just like what we were doing just a minute ago. Both of those are perfect squares. So if I factor what's inside of here, how did I get the x squared? Using the same thing, x and x. What times itself is 4. That would use 2 and 2. And again, one's a plus and one's a minus. Now, this exponent up here says everything that was inside of here is squared. So even if I break it down into its factors, they're still both squared. What this number tells you is what's called the multiplicity. The outside exponent tells you what the multiplicity of the zero is. Because remember what zeros are. Once you get it all factored in, then what you're going to do is say, okay, there's my factors. To find out what their zero is, you set them equal to 0 and solve them for x. So if I solve both of these for x, I would have to subtract 2's here. So this x would equal -2. I would have to add the 2 to both sides here to get its x by itself. So its x is +2. So the zeros, or if I graph this, where it would cross through the x-axis, is at -2 and +2. Here's what the multiplicity tells you. The multiplicity, again, where did these answers come from? They came from these factors that had this multiplicity. So the zeros, which is what you get when you do the factoring, set the factors equal to 0 and solve them. So the zeros are positive and -2. And what was the multiplicity of these factors? Their multiplicity was both 2. So again, the outside exponent is what gives you your multiplicity. And I'm going to tell you what the multiplicity does in a second. If you still have a squared inside your parenthesis, that means you need to factor it down again. That's what gave me the x +2, x -2. Once you get them all the way factored, when there's not any more exponents on the inside, then you say, okay, this is what I need to set equal to 0, solve it for x, That gives me my answers, 2 and -2. And again, the multiplicity is the outside exponent. And we'll talk about multiplicity here in just a second, what that means. Number 7. Okay, so it wants me to find the zeros and then state the multiplicity of each. Now on this one, unlike last one, even though this one looks a little more complicated, it's actually easier because you don't have any squares inside your parentheses, which means all the factoring part is done for you. These numbers, and this one, if you don't see it, it's a 1. Those are the multiplicity numbers, the outside exponents. So what you want to do to find the zeros is set each of the factors. So this one, set it equal to 0. This factor, which is x minus 1, set it equal to 0. And in this one, x plus 7, set it equal to 0. Solve them for their x's. This one's nice. It's already solved, right? X is already by itself. So 0 is one of the zeros. This one, I need to get rid of that minus 1 with a plus 1. So x equals 1. And this one, I need to get rid of that plus 7 with a minus 7. So x equals -7. So the 3 zeros are 0, 1, and -7. So this one's multiplicity is its outside exponent. So the multiplicity was 6. This one's multiplicity was 2, and this one's multiplicity was 1. Okay, it kind of asks you in a funny way how to enter the answers. So it first says the smallest zero. So here's my zeros: 0, 1, and -7. All right, -7 is the smallest number out of those. So -7 is the smallest zero, and its multiplicity was 1. So the middle, so it would be -7, then 0 is your middle one, and its multiplicity was 6. And your largest zero was +1, and its multiplicity was 2. All right, number 8 is another one like this. Right, and remember what zeros are. They're the x-intercepts, where the graphs would cross the x-axis if we were graphing this out. Again, no inside exponents, which is good. That means all the factoring is done for me. I want to go through your own and look at all the factors, because I'm going to set them equal to 0 and solve them. This one doesn't need to be done because it doesn't have a what? Doesn't have an x, which means it's not going to make an x-intercept. Only the factors that have x's included in them will make a 0 or an x-intercept. So let's see, this one's going to be x minus 3. I'll set it equal to 0. x plus 1, I'll set it equal to 0, and this one, remember, that's just its multiplicity number. The factor is just x. Set it equal to 0. And then solve them. So get rid of the minus 3 with a plus 3. So this one is x equals 3, and its multiplicity was 4. Solve this one for x. So subtract 1 from both sides. So x equals -1, and its multiplicity was 3. And this one's x was already solved for, right? The x is already by itself, so there's no work I need to do to that to solve it. And its multiplicity was its outside exponent, which is 2. Okay, so again, it has acid in a funny way. It says the 0, 3. So which one's 0 is 3? Here's where the 0 is 3. Has multiplicity 4. Then it says blank is a 0 of multiplicity 3. So here's where the multiplicity 3 is. What was its 0? -1. And then it just says the remaining 0 is blank and has multiplicity blank. So the remaining 0 is this 0, and it has multiplicity 2. All right, number 9 and 10 are similar to each other. Right, because you like to, when you're finding zeros come from the factors, right? You get the factors, and then you set those factors equal to 0 and solve them for x. So 7 and 8 already had it in the factored form for us. So we just went through and set each factor equal to 0. When you're looking at number 9, I don't see the factors, right? I have to do the factoring myself. Now, here's another type of factoring that we need to reacquaint ourselves with. If there are 4 terms, but look at the 4 terms, there's nothing in common with all of them. They don't all have an x, because this one doesn't. And they don't all have a number besides 1 that goes into them. So there's nothing in common with all 4 of them. So here's what you're going to do. You're going to put the first 2 in a group, and then put the second 2 in a group. Now, just looking at your first smaller group, just these 2 terms, you want to pull out what they have in common, and you want to pull out as much as you can. So this one has x to the 3rd, so it's got some x's in common with this. You want to pull out as much x as you can, and they both have it. So actually kind of what you're looking for is the x that has the smallest exponent. So you're going to pull out x squared from this first group. Okay, just stay with me. And put in parentheses what's left after I take the x squared out of both of these. So if it helps you, write the x squared underneath there and act like you're taking it out. So if I had x to the 3rd, but I took out 2 or x squared, I'm still going to have an x left. Minus, I took out all of the x here, right? I had x squared and I took out x squared. So all I'm left with is that -4. Now, in this second group, I'm going to do the same thing, except here's what I'm wanting to happen. I'm wanting what's left in these parentheses to exactly match what's left in this front parentheses. The first thing I notice is that this doesn't have any x's, and this doesn't have a number that 4 can go into, or a number that goes into 4. So I say, okay, then there's something in common with all numbers, letters, everything, something that you can take out of everything. It's a 1. You need to decide whether or not you need to take a positive 1 out of this or a negative 1 out of it. And the way you decide is, do my signs here need to change in order to match the signs here? Well, they do, because this is a negative x, and I want my leftover to be a positive x. That's a positive 4, but I want it to be a negative 4. That's telling you you need to change signs, which means pull out a negative 1 from that second group. Which means that's what I'd be dividing by, which just does what? It changes the signs like I wanted it to. Negative over a negative turns that to positive x. Positive 4 divided by negative 1 is negative 4. Now, here's why these two things have to match. The last part of this kind of factoring is these match, so I can pull those out. So just like I did earlier, if I pulled it out and put underneath here in my second parentheses, what's left if you took out the x minus 4s? What's left is the x squared minus 1. Now, I'm still not done factoring this because I still have an inside exponent. So I've got to do this one again. This is done. There's no inside exponents here, so that's good. I can factor this one again. So it is a difference of perfect squares like we were doing earlier. How do you get x squared? What are you going to put here and here? X and x. 1 is a perfect square because you can multiply 1 times 1 to get it. 1 plus, 1 minus. Now we're done factoring. The next one's just like this. So you're going to see another one that's similar to this. So there's my factors. It wants to know what are the zeros. So once you have your factors, you just set them all equal to 0 and solve them for x. So here I would add the 4. So x equals 4. Here I would subtract 1. So x equals negative 1. And here I would, to get rid of minus 1, I would need to add 1. So x equals positive 1. So your zeros are 4, negative 1, and positive 1. And then it wants to, and then it says each 0 has a multiplicity of what? So what you do is you say, okay, here's the 0. Where did it come from? What factor did it come from? It came from this one. What's its multiplicity if I don't see it? It's a 1. Same here. Where did this negative 1 come from? It came from that x plus 1 factor. This positive 1 came from the x minus 1 factor. So all 3 of them had multiplicities of 1. Okay, so just to draw this all together, I'm going to put my original function in my y equals and show you what you just found by finding those 3 zeros. What are zeros? They're x-intercepts. So I'm going to go to y equals and clear it out and put my original function in here. So x, raise it to the, raise it to the 3rd power. And I'm going to get out of the exponent. And then minus 4x squared minus x plus 4. And then graph it. And let's see what happens. So where should it have crossed the x-axis? Negative 1, positive 1, and positive 4. So that's what you just found. You found that. Also, you knew what the end behavior would have been, right? What is this? This is my biggest exponent. It's positive. Is a 3. So it's odd and positive, which means what happens in the graph? It starts at the bottom. It does weird stuff, and then it ends up going up at the other end, just like our end behavior rules chart told us. Okay, number 10 is just like this. All right, another find the zeros, but I don't see it broken down into factors, and factors are what turn into zeros, which means just like the last one, I need to factor this one, and it's the same kind of factoring because it's got 4 terms, but there's nothing in common. That's what tells you to put it in the 2 smaller groups. Right, just like the last one, what's in common in my first group is I can pull out x squared. If I pull out x squared, let's look and see what's left. If I took the x squared out of this first term, I'll still have the 2. If I took 2 of those out, I'm still going to have 1 left, right? Because I had x to the 3rd. Minus x squared over x squared. I'm not left with nothing. What is it when you are dividing something by exactly what it is? Anything over itself is 1. So 2x minus 1 is what is left in the first parentheses, which means that's what we need left in the second parentheses. That's what's helping us decide whether or not we need to pull out a negative to change signs along with what's in common. Looking here, I actually see something in common in those. The highest number that goes into 50 and 25 is 25. So I can actually pull out a 25. Here's what I need to do. I need to know, does this 25 need to be a positive or a negative? What needs to be my first term left right here? The same thing that was left here. So it needs to be positive 2x. So think about this. If you just divide that by a positive 25, what are you going to have left? What's a negative over a positive? You're going to be left with negative 2x instead of positive 2x. That tells me my 25 that I'm pulling out needs to be negative. Because here, what does a negative over a negative turn into? Positive. 50 over 25 is 2x. And what's positive 25 over negative 25? Negative 1. So these are the same. Okay. If you get to this point and these look the same, except for their signs, that just tells me I should have pulled out a negative to change the signs too. So let's see what's in common. 2x minus 1. So if I took the 2x minus 1 out of both of these, it'll just cancel it in both spots. So what's going to be left in your other parentheses? What's left? X squared minus 25. Almost done. So this one's done, right? There's no inside exponent. This one is another difference of perfect squares. So let's see. X and X for the X squared. The number that's the same that multiplies to get 25 would be 5 and 5. One's a plus and one's a minus. So there's your factors. How do you get from the factor to the 0? You set it equal to 0. And solve them for X. So here I need to add 1 to both sides. So 2x equals 1, and then divide it by 2. So x equals 1/2. So there's your first 0. This one, I just need to subtract the 5 from both sides. So there, x equals -5. So there's another 0. And here, add the 5 to both sides. So x equals +5. There's your last 0. So your zeros are 1/2, -5, and +5. And where does their multiplicity come from? Their multiplicity, you trace the 0 back up to its factor that it came from and look at its exponent, which were all 1s. Okay, so what does this multiplicity thing even mean? Remember, the multiplicity is that outside exponent number. So what it's telling you is there are actually 2 different kinds of x-intercepts. Okay, you can be an x-intercept by crossing the x-axis, or you can be in a, this is an x-intercept, and so is this. So there's 2 different kinds. You either cross through the x-axis, or you touch the x-axis and go the other way. Your multiplicity of the factor tells you which is which. So if your multiplicity is odd, that outside exponent is an odd number, you are going to cross the x-axis at that 0. Okay, so on the multiplicity, the rules are if you're odd multiplicity, you are going to cross the x-axis at that 0. If you are even multiplicity, you are going to be a 0 where you just touch the x-axis and go the other way. You don't cross all the way through it, but you do touch it, which does make it an x-intercept or a 0. This is what they call tangent to the x-axis, which means touches, but doesn't cross. So that's what those multiplicity numbers tell you. Which will help us do 11 and 12. Okay, 11. and these are true or false, it says if P of X is X minus 5 to the 4th power, X plus 2 to the 3rd power. So let's see. These are the factors, right? These are what create the zeros. So this one's 0. X minus 5 equals 0. If I solve it for X, I get X equals 5. Same thing here. If I solve this one for X, I would need to subtract the 2 from both sides to get X equals -2. So 5's multiplicity, these are the 2 places where it's going to touch or cross the x-axis. So if I'm on the x-axis, let's see, it's going to cross or touch it at +5 and cross or touch it at -2. That's what finding the zeros does. What the multiplicity does is tell you whether you cross all the way through the x-axis or do you just touch it and go the other way. So 5's multiplicity was +4, which means it's an x-intercept that's just going to touch the x-axis and go the other way. -2 had an odd multiplicity, which means it's going to cross all the way through the x-axis there. So here's what it says. It says this function crosses the x-axis at 5, 0, which is at the 5. Is that true or false? Well, here's my 5. Did it cross through the x-axis? No, it did not cross through because its multiplicity, where did this one come from? From here. Its multiplicity was 4, which is even, which means it was tangent or just touched the x-axis at that one. So you have to find where it goes through. So on all these, all of x minus 5, that's where the 0 comes from, right? That's where this 5 comes from. Its multiplicity is 4, which is even. So exponent 4 is even, exponent 4 is even. Look what these say. Exponent 4 is odd, exponent 4 is odd. So those are wrong. So these both say the 4 is even. This one says, thus it crosses the x-axis. And this one says, thus it's tangent to the x-axis. This is the one that you need to choose, right? The statement that it crosses through is false because its multiplicity was even, which means it's tangent. So that B right there. Okay, I'll put the last one, -12, up on the board and let y'all, it's the same kind of problem. And then I'll take a roll. All right, this time, if P of X equals X minus 8 to the 7th and X plus 5 to the 10th, it's tangent to the x-axis at -5. So is that true or false? And then why? Okay, so if this is the 0, that's the x-intercept. Which one of these factors would it have come from? It would have come from this factor, right? X plus 5, if you set that equal to 0 and solve it, you get -5. So what is its multiplicity? Its multiplicity is 10, which means it's even. And what does even multiplicity mean? It does mean it is tangent, right? Odd multiplicity means cross. So this one would be true because its multiplicity was 10, which is even, which does make it tangent. Okay, so